All right, here's our video today, how the body makes you thirsty. And I'm thirsty right now. I'm gonna have some nice, cool, refreshing Brooklyn water. Try to do my little cheap sound effects here. Actually, that was not Brooklyn water. It's a little Canada Dry seltzer. No product placement here, by the way. Canada Dry from Texas, right? Anyway, when you're thirsty, in simple terms, when the fluids in your body drop below a certain level, there's going to be specific sensors that will detect it. And those sensors are located in the brain, obviously. They're located in the hypothalamus. So I'll write that up there. Then I'll show a picture. Let's use red. Well, let's use yellow. See if that stands out. There it is. Hypothalamus. And the hypothalamus regulates homeostasis. So it's not just if you're thirsty. If you have a fever, for example, your body will make you sweat. If you're cold, the body will make you shiver. And when you're thirsty, your body has already triggered a response because you were dehydrated. So in the hypothalamus, there is these cells called osmoreceptors. So let's look first. And there's the hypothalamus right here in the brain. And again, like I said, homeostasis, it's regulating. And we'll talk about the cells, the osmoreceptors. So when there's a overconcentration of solutes in the blood, like salt, for example, actually sodium, when you have a high concentration of sodium ions, positive sodium ions in the blood. So when you have a high concentration, if it's high concentration, write that down. And that high concentration is called hyponatremia. Write that down. Not hyper. Think of when there's an excess. When students or and Halloween have too much sugar, they're hyper. Right? Think of that. So hypernatremia. Fix that E there. It's an E. That's an E right there. That's when you have a high concentration of solutes in the blood. Not just sodium, could be high potassium and other electrolytes. And the osmoreceptors when this happens, the osmoreceptors will be triggered. There's osmoreceptors. We'll talk more about. They're located in the hypothalamus. And there's also these stretch receptors, and they're located in the walls of the blood vessels. So both of these are acting like guards to see if there is a high concentration of solutes in the blood. And if that happens again, there is a various mechanisms that will come into play. So you'll drink water. You'll drink your delicious water, your seltzer, or whatever you want to drink. And there's another fancy word coming up. It's called osmolality. Fancy word. You're hearing the word osmo, the prefix, a lot. Osmolality. And that's really which is going to assess the osmotic pressure. And the osmotic pressure is just going to talk about all the solutes that should be in your blood, not just one like sodium, but all of them. And the normal range, let's get the normal range here for you. Normal osmotic pressure range is 275 to 295. And it's called milliosmoles. So you're hearing that prefix a lot. So it's milliosmoles per kilogram of water. So when the osmotic pressure is high, a thirst trigger will happen by the osmoreceptors and the stretch receptors. And there's a thirst center within your hypothalamus. It will still stimulate the sensation to drink. So just to sum it up really quickly here, again, when the fluids in your body drop below a certain level, there's going to be specific senses which we now know are osmoreceptors and the stretch receptors in the walls of your blood vessels, and the osmoreceptors that are in the hypothalamus that you're seeing here in the picture. And what they'll do is they'll trigger the sensation of thirst. Now, they're in the thirst center, which is located in the hypothalamus. There's also, you see in the pituitary gland here, they're going to release a hormone called vasopressin. So let me write that down. Maybe we'll use red. Vasopressin. So your body is smart. So what's happening is if you don't drink, it's trying to conserve water. So from the pituitary gland, vasopressin will be released, and that's going to talk to the kidneys. And they're going to say to the kidneys, hey, listen, you have to reduce urine output to conserve water. So the body is telling you to drink, but if you don't drink, the body's working anyway. Let's get the picture of the kidneys. And by the way, there's a picture of the stretch receptors within the blood vessels. And here's a picture of vasopressin release from the pituitary gland. Again, do you remember where vasopressin is going? It's a hormone, right? It's a chemical messenger. That's what hormones are. And it's going to say to the kidneys, reduce urine output to conserve water, right? Until you drink. And here's the kidneys located on the sides of our body in the back, right? And they're about 5 inches long in an average adult. Anywhere from 5 to maybe a little over 5 inches long. So they're not that small, right? Sometimes people think of them as little kidney beans. No, they're big, and they have a vital role in in getting rid of waste. Now, there's another part of our body system, and I'll write it over here. We'll use white, or maybe we'll use black. Okay, so the sympathetic nervous system is going to help us also, and guess what? The hypothalamus is going to regulate that, and the brain stem. And what that'll do, let's write it up here first. We'll write the sympathetic nervous system. And again, the sympathetic nervous system, one of the things it will do is it will have decreased saliva secretion. That's going to get you to want to drink, right? It's trying to do everything to say, hey, will you drink? Decreased saliva secretion. I think I'll have another sip of this Canada Dry. I'm feeling decreased saliva secretion right now. Also, there'll be, if it gets too serious, there'll be decreased blood flow. And that decreased blood flow could make, and also a decreased saliva secretion, could give you that dry mouth feeling because there's reduced moisture in the oral cavity. So with all these triggers, you gotta want to have a drink, right? So the body is trying to make you drink, and if you're not drinking right away, remember it's going to release some hormones, vasopressin, to reduce urine output in the kidneys. All right, and there's also another hormone, angiotensin 2, that also helps conserve water in the body. And this is just a brief video a very simple video in one way. There's a lot more factors going on, but this is just general overview of what's happening when you're thirsty. Okay.